Yesterday we were talking about convection, and when we saw with heat convection, we saw the mechanism how the heat convection is happening, right? So now heat convection, you have to see the main thing what is involved is the heat conduction, sorry, energy. Just like the heat conduction is there, there is heat convection. Which is the convection part? Conduction is similar to diffusion. I'll repeat again. Conduction is similar to diffusion. So this is diffusion and this is convection. If you see acceleration also, we have convective acceleration and temporal acceleration. Two things are there. So what are these part? These three terms, one, two, three. These are related to convective heat transfer. If this was u, then it would have been convective acceleration. Make sense? Instead of temperature, it was velocity. Then it would be convective acceleration. If instead of velocity, it is temperature, it is convective heat. Convection means carrying. Convection means carrying. So there is a palanki named U, V, and W. So those people carry. Okay, and this is the bride. Okay, understand that? Okay, so it is carrying. What is carrying? It's carrying the gradient of velocity, gradient of temperature. If it is carrying, the velocity is carrying the gradient of velocity, then it is called acceleration. Which kind of acceleration? Convective acceleration. Makes sense? That is the main point here. Okay, diffusion, convection, temporal. Temporal, convection, diffusion. These three parts. Okay, this is called convection diffusion equation. A convection diffusion equation, there is no pressure gradient. Now, convection diffusion without pressure gradient is what we did in Prandtl's boundary layer diffusion equation. Sorry, Blasius equation. So, Blasius flow, the Blasius flow which is there, it is similar. The Blasius flow is similar to heat heat convection diffusion equation or the energy equation because there is no pressure gradient in the Blasius flow. You understand? So there is no pressure gradient in the glaciers flow, and inside the thermal boundary layer, we don't have dou square u by dou x square is not there. So similar way, similar to glaciers flow, in thermal boundary layer also, you don't have dou square t by dou x square is not there. There is no diffusion of temperature along the x direction. There is diffusion of temperature only in the y direction. Although it is there, it is negligible in the steady state. In the steady state, diffusion along the streamwise diffusion of heat is negligible in the steady state. Make sense? It's only cross stream diffusion. Hope you get the point. Okay. Now, since it is only cross-stream diffusion that is important, and these two equations, Blasius equation does not have this. There is no pressure gradient in Blasius equation. So, since this is not, these are similar. So, whatever the solution which is applicable for this is applicable for this, with of course some corrections. What are the corrections required for? See here, there is u, there is t, there is nu, here there is alpha. So although it is similar, there has to be some corrections which is involved. Make sense? So what did we do first? We saw what is when you non-dimensional. Always we have to non-dimensionalize. Okay, this is one side which we saw the non-dimensional equations also. In Blasius you get 1 by REL. Here you get REL PR. Very important. So here we introduce what is Prandtl number. Prandtl number is nu by alpha. Okay, nu is uh, momentum diffusivity, alpha is thermal diffusivity. Momentum diffusivity is mu by rho, the viscosity, dynamic viscosity by density, and alpha is k by rho cp. Correct? Heat conducted by heat stored. More the heat conducted, see alpha, see this field is very important. See alpha is what? K by rho Cp. What is K? K depends how fast the heat is taken away. Rho Cp says how much is stored, how big. Rho Cp being big means it's a bigger ditch which is there. If something is going here, how fast it is going. There is water which is flowing. This is the flow rate Q. How fast this is flowing is K. How deep it has to fill is about rho Cp, which is the heat capacity. Make sense? Yeah. So now, similar way, we found the solution. We know how we found the solution to Blacher's equation. So these are the solutions we had. We had done it in boundary layer theory in fluid mechanics. So this is about tau W. This is delta, the hydrodynamic boundary layer thickness, and this is the wall shear stress. From the this was the numerical solution. This is also applicable for our same Blacher's equation solution is applicable for heat transfer also. Thermal, what do you say? Heat transfer, convective heat transfer in the thermal boundary layer, it is applicable. Make sense? So these are the things which we have done uh, in our fluid mechanics, and these are the results we had. CFX and CFX. This one you can sometimes write this also as, sometimes they write this as CFL. You can write this as CFL also. Okay, without a bar. You can write that somewhere. It's sometimes written as CFL also. CFL is equal to CFX bar. Here only you can write CFL is equal to CFX bar. Sometimes notations, different notations are there. One is a myth. Next. Now here, when you say thermal boundary layer solutions, see, this is the equation in terms of eta, F and Prandtl number we get. Compare this with Blacher's equation. What is a Blacher's solution? 2 d cube F by d eta square plus F into dou square F by dou eta square is equal to 0. Compare this and this. It's almost similar, is it not? The Blacher's solution, what you get for Prandtl boundary layer theory, that is Blacher's equation, what you get for hydrodynamic boundary layer, and this is for the thermal boundary layer. See the difference here. Now, what is theta? Theta is the excess temperature. This is theta, non-dimensional temperature. Yes. Take that. Very important to understand. Students, compare. Take time, because this, if you understand everything. I'm not going to rush here. I'm going to go slow. Done. Done. Okay. Now, here. Now, when we do that, we get similar equation. See, dou theta by dou t. What is required for conduction, or what is required for heat transfer? Temperature gradient as per Fourier law. So the temperature gradient is written by dou theta by dou tau, and dou theta by dou tau, so dou theta by dou eta can be converted to dou t by dou y at y is equal to 0, and this is what we get, right? Next, what did we do? Did we do? Q is equal to HW into TW minus T infinity, or HW, which is the heat transfer coefficient near the wall. It is not on the wall, it is near the wall. is equal to q dot wall divided by tw minus t infinity, which is given by this. This we have already done, known in the previous. This one here we know it. That we substitute and we get this. Make sense? Kf means K fluid. Okay, so that's what we got. Then we took that K and F, we took it on the other side and got something called Nusselt number. Make sense? We derived something called Nusselt number. We got something called Nusselt number, and we explained what is Nusselt number, and then we got thermal boundary layer thickness. Make sense? This is what we did. Today we will do problems. Okay. Let us directly go to problems now. Old gate. These are questions are very, 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 very easy. Okay. Okay. So problems. So let us change the color into black. Okay. So old gate questions. So let us see OGQ. Okay, old gate questions. So now the property. This question has come in 2002. Okay, and for 2 marks. Okay, the question is like this: the properties of mercury. The properties of mercury. I will write Hg are at 300 Kelvin. At 300 Kelvin are density, density 1300 and 13,529 kg per meter cube. Specific heat, specific heat Cp is equal to 0.1393 kilojoules per kg Kelvin. Dynamic viscosity, dynamic viscosity 0.1523 into 10 power minus 2 pass, and thermal conductivity and thermal conductivity of 8.540 watt per meter Kelvin. The Prandtl number, the Prandtl number of mercury at 300 Kelvin is A 0.0248, B 2.8, C 24.8, D 248. Don't use a calculator and tell me, because there's a similar one which is done in IES question papers. These kind of questions come very, because it's order of 10, is it not? Everything. So you know 248 only. So don't use the calculator and see whether what is the answer. First, let us check out without using the calculator. Don't use the calculator. What's the answer? A. No. A is the answer. Correct, correct. Why is it? A is the right answer, Pa. A is the right answer. They have given the wrong option and they have at the end they have solved it with A as answer. Everybody got A without calculator or with calculator? Without calculator. So these are the type of questions which come in A. First, you have to know what is Prandtl number. What is Prandtl number? A by rho C. Everything is given. You don't have to take what you don't have to take. Mu you will not take. Is it not? Sorry. What is this one? A by mu C. Rho cancels. So that you have to get the answer. Everybody got it? Who did not get? Do it fast. Done. What other way around? Music. I always get it as alpha. Sorry, nu by alpha. Nu is what? Nu is yes, correct. Mu by rho c. Mu by mu c by k. Yes, yes. Mu c by mu c by k. I always remember this. The other things you can get that. Alpha is k by rho c. So you can write, yeah, the rho goes up. Yes, rho cancels with k. I don't remember these formulas, let me tell you. But it's better you remember. I remember nu by alpha. But sometimes I confuse after any time of thing whether it is alpha in the numerator or alpha in the denominator. That confusion is there. But then I think the plate is heated. The plate is heated. The what to say, the heat goes up. The water goes up. Up there. So water is up, heat is done. Next question. Okay. This is a common data question. Done, no? Everybody done? Who did not get, tell me. Because it's important, even if it is a simple one, to do it and get confidence. Very important. Okay. It may look trivial that getting an answer for everything is not important. It's important. Very important. Common data question. This has come in a 2003. 2003 common data question. Common data questions. Let us see one. Heat is being heat is being transferred transferred by convection by convection from water at 48 degrees centigrade to a glass to a glass plate to a glass plate whose surface temperature whose surface temperature is exposed to the water exposed to the water is at 40 degrees centigrade. So your surface temperature of the glass is less, that of the water is higher. Okay, keep in mind. So it's hot water in a glass, okay, over the glass plate, right? The thermal conductivity, the thermal conductivity of water is 0.6 watt per meter Kelvin, and the thermal conductivity of the glass and the thermal conductivity of the glass is 1.2 watt per meter Kelvin. The spatial gradient meter Kelvin. The spatial, not the special, spatial gradient, the spatial gradient of temperature, spatial gradient of temperature in the water at the water glass interface, at the water glass interface is dt by dy is equal to 1 into 10 power 4 Kelvin per meter. Question 1. The value of temperature gradient, the value of temperature gradient gradient in the glass, in the glass at the water glass interface, at the water glass interface is in Kelvin per meter is A minus 2 into 10 power 4 B 0 C 0.5 into 10 power 4 D 2 into 10 power 4. Question 2. Question 2. The heat transfer coefficient. The heat transfer coefficient. Heat transfer coefficient. H in watt per meter square Kelvin is A 0, B 4.8, C 6, and D 750. What's the answer? So you have water glass interface. This is 48 degrees centigrade. Thermal conductivity of water is zero point 0.6 watt per meter Kelvin, and glass is 1.2 watt per meter Kelvin. The spatial gradient of temperature in the water is 10 power 4. Huh? First one C. How did you get that? Come again? Of course, of course, yes. So what happens? Yes, very much. So yeah, but see that answer I don't know. Answer I'll check it out whether you have got the right answer or not. The answer is right. No, 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 no. See, answer is right. Others think. It's simple. Gate exam questions are very simple. It looks intimidating. It's not that intimidating. Especially on convection and radiation. Things are very, very simple. But questions comes very less in heat so general till now. Last time it has come more, but that was an exception. This time another exception can happen. That's the difference.
Is second D, sir?
Second one is D. Okay, let us see. First one you got?
Yes, sir.
Yes, the answer is D itself. Correct. Heat transfer coefficient is 750. Very correct. Super. Hey, no, 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 wait a minute, wait a minute. Wait a minute, wait a minute, wait a minute, wait a minute. Where am I? Where am I? Correct answer. Yes, yes. Very good. Good students. I'm happy. You got the D, second one? Hmm. I'll not ask Trishul how did he get because I want you to figure out. It is simple. The first one everybody got? No? Okay. I'll solve it, but attempt for some time. Try. Go back, see the theory again. Got it? Right. Go back. Everything answer is in the theory only. ಎರಡು ಸಿಕ್ಕಿತಾ ಸಿಂಪಲ್ ಇದೆಯಾ ಕ್ವಶನ್ ಸಿಂಪಲ್ ಇದೆಯಾ ಚೇತನ್ ಸಿಕ್ಕಿಲ್ವಾ online students ನಿಶ್ಚಲ್ ಸಿಕ್ಕಿತ ಆನ್ಸರ್
Yes, sir. ಮಾಡ್ತಿದ್ದೇನೆ.
ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಸರಿ ಫಸ್ಟ್ ಒನ್ ಸಿಕ್ಕಿತಾ
ಹಾ, ಫಸ್ಟ್ ಒನ್ ಸಿಕ್.
ಶರಣಿಗೆ ಎರಡು ಬಂತ ಸಿಂಪಲ್ ಇದೆಯಾ ಕ್ವಶನ್ ಗೇಟ್ ಅಲ್ಲಿ ಡಿಫಿಕಲ್ಟ್ ಅಂತ ಕಾಣುವಂತ ಕ್ವಶನ್ ಯಾವತ್ತೂ ಡಿಫಿಕಲ್ಟ್ ಇರುವುದಿಲ್ಲ ಸಿಂಪಲ್ ಆಗಿರ್ತದೆ ಕಾಣುದು ಮಾತ್ರ ಬಂತ ಆನ್ಸರ್ ಇಲ್ಲ ನಾನು ಹೇಳ್ತೀನಿ ಏನು see here the way is only this much next time you have to do this see here the heat transfer which is happening in the glass due to conduction is equal to heat transfer that happens through convection in the water correct so what happens is or conduction in water same conduction okay so k of the water into area of the interface into dt by dy in the water is equal to k of the glass into area into dt by dy of the glass that's it area cancels the conductivities are given you can calculate 1 dt by dy the water is given you can calculate dt by dy in the glass that's it simple one step answer easy okay get the answer first so it is about once you get it it's not about that should strike to your mind that's it once it strikes it's done okay second option is you have h into a into delta t is equal to this one kw or kf one of the two both are same right so kf into a dt by dy in the water or dt by dy in the so you this cancels you know what is delta t you find out h do you got it that time only oh I thought you did not get it super next question we will go after Sujit gets the answer got it Kirtan that time only you got or now you got no ಶೈಲೇಶ್ ಅರ್ಥ ಆಯ್ತಾ
Yes, sir.
ಬಂದಿತ್ತಾ ಮುಂಚೆನೆ
Yes, sir.
ವೆರಿ ಗುಡ್ ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ next question is something like this okay um, this has come in 1988 students 1988 for the fluid for the fluid flowing over a flat plate for a fluid flowing over a flat plate or a flat plate with Prandtl number with Prandtl number Prandtl number greater than unity greater than unity the thermal boundary layer thickness the thermal boundary layer, the wait, thermal boundary layer, the thermal boundary layer or laminar forced convection or laminar forced convection A is thinner than than thinner than hydrodynamic boundary layer. B has thickness equal to 0. C is of same thickness as hydrodynamic boundary layer, and D is thicker than hydrodynamic boundary. What's answer, students? Prandtl number is greater than 1. We have done this already, but let us see others. Similar questions, a lot of these have been repeated again and again. Simple, easy. These kind of questions have come. See, they have given the fluid flowing over a flat plate has the following properties. The thickness of the thermal boundary layer would be, yeah, this would be very easy. Okay. Next question. This is A. I hope everybody got this, right? We have explained this last time, is it not? Okay. These are simple questions that comes. Okay. This has come in 1992, and these questions, has been repeated how many times? I'll tell you. One is over, right? Two, three, four. Then on this Prandtl boundary layer, hydrodynamic boundary layer thickness only. Okay, 3, 4, 5. Lot of times, students. Okay, 6 here. So till now, 6 times has been repeated. So it may be repeated this time also. Don't know. Okay. So question number, it has come in 1992 for 2 marks. Okay. A fluid flowing, a fluid flowing over a flat plate, over a flat plate has the following properties, has the following properties: dynamic viscosity, dynamic viscosity is equal to 25 into 10 power minus 6 kg per meter second. specific heat. सर एक मिनट पढ़े कहाँ ना सर specific heat ಎಲ್ಲಿದೆಪ್ಪ ಕ್ವಶನ್ ಅಲ್ಲೋ ಕ್ವಶನ್ specific heat is equal to 2, this is 2.0, okay, 2 kilojoules per kg Kelvin. Thermal conductivity is equal to 0.05 watt per meter Kelvin. The hydrodynamic boundary layer boundary layer at a location is measured to be 0.5 millimeters. The thickness of the thermal boundary layer at this location is A 0.1 mm, B 0.5 mm, C 1 mm, and D none of these was answered. Come in 1992. It's a commonly repeated one. Used to always have pen drive, but nowadays is it the same? Why Prandtl number is equal to 1? Is it not? Good. Did you get Prandtl number is equal to 1? If Prandtl number is equal to 1, then you can calculate. If Prandtl number is not given, then you know what is the relation. TR is repeat, what is it? Delta T is equal to delta divided by Prandtl raised to 1 by 3. That you remember and you can get the answer correct. Everybody got Prandtl number is equal to 1. Chalo, next question. So you see heat transfer rules and it is difficult. Online students, did you get the same answer? Did you get Prandtl
Yes,
is equal to 1 here?
yes, sir.
Yes, sir.
Yes.
Yes,
Right?
sir.
Yes, very good. Next question. So we'll rush here. No problem in rushing? Yes. Very good. See, things are pretty easy. Okay. Uh, yeah. Next. The temperature distribution, this has come in 2007 for 2 marks. Let us see this one by one. Okay. The temperature distribution, the temperature distribution, the temperature distribution within the thermal boundary layer, within the thermal boundary layer over a heated over a heated isothermal flat isothermal flat plate plate is given by is given by T minus TW divided by T infinity minus TW is equal to 3 by 2 y by delta T minus half y by delta T the whole cube. Y by delta T the whole cube. Where TW and TW and T infinity are the temperature Yeah, students, there was a power cut, so I couldn't do anything. So we have lost the problems. Anyhow, problems if you lost, there's no problem because anyhow you can solve it again. So more problems you solve it better. Okay, theory you should not miss. That's it. Okay, so this is a question which had come. Okay, I hope you have written a bit there. Okay, so let us go ahead with that. Okay, so what is given? There is a this is a question from. This is a question from 2007 for 2 marks. Let us see directly from here. That would be better because we will not lose it. Is it not? Let us go with the 2007 question number. You got it? No, you're not doing that. Okay, fine. So let us go. This WhatsApp is not required. So let us go with IITK, IITK gate. Okay. So if I go there and if I go papers and syllabus in first year, okay, over here we will go. IITK 2007. From here we get it. Okay, so mechanical engineering. In this, we have to see the 2 marks question which comes after 30th. Okay, so here this one, this question. Okay, so let us do this question, students. Okay, so can you solve this question, students? So we will go directly because it will save us a lot of energy. Okay, in writing, and you can write the question number and then don't have to write the question again, so that we could solve more questions and yeah, let us do that from now onwards. Okay, so can you solve this question, students? Okay, a temperature distribution within a thermal boundary layer or a heated plate is given like that. Okay, if you want you can write the question, no problem. Okay, the local Nusselt number based on thermal boundary layer thickness is local Nusselt number based on the thermal boundary layer thickness is. Banta, is it B? Yes, it is. How did you get that? Differentiation this. That's it. You get the answer. How is that? Exactly, exactly. Very good, very good, very good. So what is happening here is when you say Nusselt number, it is H X K. But how did we get that initially? We got it as QW divided by TW by T infinity. Based on delta means TW by T infinity cancels. K cancels. So what remains is dt by dy at y is equal to 0. That will be the Nusselt number. Make sense? Put that. Instead of x, it is delta. Delta y. That's it. Okay, let us look at it further. Okay. See what is happening. What is Nusselt number? How did you get it? Is non-dimensional heat transfer coefficient. Okay. How did we get the Nusselt number? We got the Nusselt number by saying H A into delta T, right? HA into delta T, which is TW minus T infinity, was equal to, if you just observe here, was equal to QW, or we'll say QW only. We'll have this instead of A, we will write it as QW. Okay, so let it be here. This is QW, and QW is also equal to this gradient. The gradient is given as this is theta. You understand that? This is theta. So if you understand d theta by dt, this is theta, this being theta. So d theta by dt is what? D theta by dt is d theta by dt is equal to, everything goes 1 by t infinity minus tw into dt by dt, or d theta by dx is equal, or dy here in this case dy is equal to tw minus this one divided by dt minus dt by dy. Is it not? Yes or no? Convinced? Okay. Now heat transfer coefficient is equal to K, area is anyhow there. So heat transfer is area is on the dt by dy. What is dt by dy? Dt by dy is K into d t infinity minus t w into d theta by dy. D theta by dy is given here. Make sense? So here, this one is h into t w minus t infinity. Obviously, there should be a minus here. So that because of that minus, these two cancels. And what you get is h by k is equal to d theta by dy at y is equal to 0. This is all at y is equal to 0. Now find this out, d theta, this is theta by dy at y is equal to 0. What you will get? You will get 3 by 2 d theta by dy delta t minus, you get half into, at y is equal to 0, of course, okay. So half into, we get 3 times, half into 3 times y square by delta t cube, is it not? Yes or no? This delta T you get, take it here. Nu is equal to, based on thermal boundary layer thickness, delta T divided by K is equal to 3 by 2 minus 3 by 2, correct? No, 3 by 2 only we have put here. 3 by 2 y square by delta T square. So what happens? This y square by delta T square at y is equal to 0, okay, Nu will come as 1.5. Makes sense? That's very, very simple. Convinced? ಡಿ ಥೀಟಾ ಬೈ ಇದು ಹೇಗೆ ಬಂತು ಅಂತಲ್ಲ ನೋಡಿ, ಥೀಟಾ ಅಂದ್ರೆ ಏನು? ಡಿ ಆಫ್ ಟಿ ಮೈನಸ್ ಟಿ ಡಬ್ಲ್ಯೂ ಡಿವೈಡೆಡ್ ಬೈ ಟಿ ಇನ್ಫಿನಿಟಿ ಮೈನಸ್ ಟಿ ಡಬ್ಲ್ಯೂ, ಆಯ್ತಾ, ಇಂಟು ಡಿ ಆಫ್ ಡಿವೈಡ್ ಬೈ ಟಿ ಇನ್ಫಿನಿಟಿ ಮೈನಸ್ ಟಿ ಡಬ್ಲ್ಯೂ, ಕರೆಕ್ಟಾ? ಡಿ ಬೈ ಡಿ ವೈ ಇದು ಕಾನ್ಸ್ಟೆಂಟಾ, ಹೊರಗೆ ಬರ್ತದ, ಒಳಗುರಿಯೋದು ಡಿ ಟಿ ಡಿ ಡಬ್ಲ್ಯೂ ಬೈ ಡಿ ವೈ, ಡಿ ಟಿ ಡಬ್ಲ್ಯೂ ಬೈ ಡಿ ವೈ ಎಷ್ಟು? 0 ಅಲ್ಲ, ವಾಲ್ ಟೆಂಪರೇಚರ್ ಚೇಂಜ್ ಆಗೋದಿಲ್ಲ, ಇಟ್ಸ್ ಅ ಕಾನ್ಸ್ಟೆಂಟ್. ಸೊ ವಾಟ್ ದಿಸ್ ವಿಲ್ ಬಿ 1 by t infinity minus tw coming out because it is constant, and then you have dt by dx dy plus minus dtw by dy, and dtw by dy is equal to 0. That's all. ತುಂಬಾ ಸುಲಭ ಇದೆ ಹಿಟ್ರಾಜ್, ಯೋಚನೆ ಮಾಡುವ ಹಾಗೆ ಟಫ್ ಇಲ್ಲ. ಕ್ವಶನ್ ಕಾನ್ಸೆಪ್ಟ್ ಅರ್ಥ ಮಾಡ್ಲಿಕ್ಕೆ ಟಫ್ ಉಂಟು, ಹೋಗ್ತೇನೆ, ಮತ್ತೆ ಸುಲಭ ಆಗ್ತದೆ, ಹೌದಾ? ನೋಡಿ ಎಷ್ಟೆಲ್ಲ ಕಷ್ಟದ ಕ್ವಶನ್ಸ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ನೋಡಿ, ನಿಮ್ಗೆ ಕಷ್ಟ ಅಂತ ಅನ್ಸ್ತಿಲ್ವ? ಇದು ಬಂದ ಕೂಡಲೇ ಟಿ ಮೈನಸ್ ಟಿ ಡಬ್ಲ್ಯೂ ಮುಂದಾಗ್ತದೆ, ಯು ವಿಲ್ ಶ್ಯೂರ್ಲಿ ರನ್ ಅವೇ ಫ್ರಮ್ ದಟ್. ಸೊ we are doing the questions confidently now, right? Next question. Two 2011, you will see. Done? Don't worry. Sit.
Delta T is along y direction. Thermal boundary layer is along y direction.
Yes.
But normally Nu.
This is Nu delta. Nusselt number with respect to delta. Nusselt number, just like Reynolds number, can be with respect to diameter, can be with respect to length. These are non-dimensional numbers. You have to specify with respect to what it is. Getting that? So here, characteristic length. Yes, that x is the characteristic length. Similar to Reynolds number. Makes sense? So what is the characteristic length here? Thermal boundary length. That's make sense? Chalo. Next one has come in 2011 gate question paper. Let us see. 2011 gate question paper. 2011 mechanical engineering itself. And we will go with question of the ratios. Ratios. not in captions, ratios. No, not there. So we have to all see whether you get a ratio to student somewhere. This one. So can we do these questions? Yes. 2011 for 2 marks. 2011 does not have sets. This is 2011 2 marks. Till 2013 it was offline, in the sense you have to write in the OMR. It was online from 2014 onwards. See, IITs are much ahead of their time, and they are the first people to start those things. Everybody was astonished how very going on with, is it not? No, no, it's not. It's not D. No. You have to correct answer. A. NU is equal to 0.664. Okay, which is dependent on the length, is it not? RE raised to REX, RE raised to 0.5, PR raised to zero point 0.3. What is the mistake you've done? No, that is not. Never do that in Gate. It's not a CET where you can get it. You cannot. ಬಂತು ಇದ್ರೆ ನಿಮಗೆ ಇಲ್ಲ ಬಂತು.
So it is 0.332.
0.332 when it is taking NUX. Okay, it is based on the plate length. So NUL. Huh? $132, no, 140 you get it. Take it out proper. You got 140 proper, is it not? No, 132 you got? No? Then you said 8 and 140. Who said it? You said.
I got 8 and 132.
You also got the same? Then?
Yes, sir. They talk the options based on Prandtl number.
Uh-huh. Okay. Fluids are different.
B, C, and D are 4, 4, 4. B, C, that 8.
No, B is 8.
8 is
Figure out, get the answer, get the answer. Don't worry, you can get it. It's only this equation which is important. This, if you know, other things you can get. And there's one more point which is there. Okay, anyhow, so let us see. Hydrodynamic boundary layer thickness to thermal boundary layer thickness. Of
reverse number is 10 to the power 4. Root of that is 10 to the power 2. Prandtl number is 8. It's 200 into 0.664.
what is that?
16 is 24 into 2 is 70.
Okay,
To do it in this method.
okay. Let us see. 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 Prandtl number is Prandtl number of Q. We have got. How did we get that? We get in terms of yeah. So ratio of thermal boundary layer thickness to so delta by delta T of P divided by delta T of Q is equal to first one is half, the other one is 2. Now this is actually equal to Prandtl number raised to 1 by 3. This is also Prandtl number raised to 1 by 3. So this is P and this is Q. And this has come as
You don't need to take the ratio. Take direct weighting. Take direct. Prandtl number of Q is Prandtl number is 1 by 3 is equal to 2. So Prandtl number is 3.
yeah, Prandtl number is equal. So Prandtl number of Q is equal to the ratio. So Prandtl number of Q is equal to, you get delta by delta T for Q is equal to 2. So Nusselt number, this is here, you get it as delta by delta T is equal to 2. So we get Prandtl number is, this is raised to 1 by 3. So Prandtl number you get as H. And the other one you do. Do it, students. Huh? ಇಲ್ಲ 40 ನೇ ಬರ್ತದೆ. So NU for getting this in.
Substitute both.
Okay. So what do you say? Nusselt number is 0.664. You are saying okay. Now one of the ways you do is, see, 132. If it was there, you would have been trouble. Okay, and they keep it there. Okay. Now one of the main thinking you have to have is the Nusselt number is not always. This number is not always strong because it depends on what type of flow it is, whether it is what type of laminar flow it is. Even in the laminar flow, okay, yeah, they have not said a flat plate. Also, they have said, but still, you're not sure about this always. So, what you have to take is Nusselt number. Yeah, the Prandtl and Nusselt number for P is 1 by 8. Yeah, Prandtl number is 1 by 8 for P. Okay, 1 by 8 is for P and 35 for Q. So Nusselt number, uh, yeah, Prandtl and Nusselt number for P, Nusselt number of Q is, we can say, some function. We should write it like this. It should be Nusselt number is equal to some function. We don't know what is the number. Some number into Reynolds number. Okay, Reynolds number raised to 0.5, Prandtl number raised to Prandtl number raised to 1 by 3. Okay, you have to do in this fashion. Yes. Okay, so Nusselt number of P divided by Nusselt number of Q is equal to, you do that, Reynolds number cancels, Prandtl number raised to 1 by 3 divided by Prandtl number raised to 1 by 3, like this. You don't assume this, because this is not always the case. It may change. It's a numerical answer, you know. The answers we have got is numerical. So it may change in different cases or a flat plate itself. Okay, so like this you will get 140. Just check it.
But similarly, I've said Reynolds number for both the floors is same, so we have to do
Which one?
for both the floors Reynolds number is same.
Yes. So
So I equated the Reynolds number.
yeah, that's why it cancels. Correct.
That way you have to not you're not using the 0.66. So
Yeah, you should not use 0.66.
that is the meaning.
Exactly, exactly. Chalo, good enough. But even if you take 132 and here in this one, you would have got the right answer. Correct?
Even both also.
Yeah, if they had given 132, then you would have clicked it and you would have got wrong. So always keep in mind, it is the best answer that is the answer. Okay, and as much as possible, these, keep in mind, these are solutions which may not be the actual case. This is based on theoretical one. Okay, so yeah, next one. Next question has come in uh, 2014 for 2 marks. Let us check it out. So let us check it out. 2014 for 2 marks. I'll give this and then you will do it. Okay. So evening class, you should get the answer for this. So it's already time, but evening class, you must get this question. 2014 set 1. Okay, for 2 marks. So I don't think I can do a search for this. Let us see. Uh, Temperature. Yeah, this one. Set 1, 2014. Keep in mind that these A, B, C, D may be shuffled in your papers. It will not be the same. Keep in mind. The person who is sitting near you will get a different A, different B, different C. He will not get the same one. So if you think you can, just like our who's that person who is doing a lot of meme, Vishal Dadlani, something like that. He makes
Singer.
not singer. There is a. It's okay. This is Vishal Chanchalani. Chanchalani. What is Chanchalani?
His name Ashish.
Ashish Chanchalani. So he does that a lot. Okay. Huh? Q double dash. Wall flux is Q double dash. I said that. It's a number, that's it. It does not mean differentiation. So we'll stop the class, students. I'll just stop the recording.